Good afternoon, ladies and gentlemen. This is Qing, a technical support engineer of Asia and Oceania Center. Today, I'm going to have a presentation about SuperMap GIS boosts smart transportation. The presentation will be introduced from the following 4 aspects. The first one is about how to construct a basic transportation GIS system. And the next, we are going to learn about how to further construct a more complete system of transportation business. We call it transportation one-man platform. And then, because of the 3D technology development, we will talk about why transportation construction needs 3D technology and what 3D technology can do in transportation construction. At last, with the development of big data, we are going to talk about how to integrate transportation with big data technology. So now, firstly, let's look at how to construct a basic transportation GIS system. First of all, let's look at the system architecture of transportation service platform. All the system cannot be constructed without hardware equipment and software. And the second layer, which is the most important layer, is data management. Data is the soul of GIS. There are various data related with transportation, including the spatial data and non-spatial data. All this data need to be processed, classified, and stored based on a certain data standard. Different types of data need different storage. So the next layer is what kinds of services need to be used for developing applications. It is based on the requirements of the system. The basic applications of transportation GIS system should organize road network management, traffic facilities management, statistics analysis, and route design, and so on. We may need these services for these functions, like map service, data service, spatial analysis, and networks, space analysis, and other services need to be built. And the last layer is the user layer. We need to know which terminals should be used and who will use this system. And all these modules form a complete system. And the next, we will mainly talk about the data management of transportation GIS platform and how to realize applications through services. Firstly, let's take a look at how to integrate multi-source data in a system. We can integrate the spatial geographic data in a map by thematic map. Data for each category can be displayed on a map as a layer, and each layer can be controlled through layer management and the scale. Besides, facilities information is usually saved in the form of documents. GIS can realize visual management of facilities after symbolization and associate the attributes with the spatial information of facilities. So users can easily query this data and the information of various facilities on the map and clearly understand the spatial distribution of them. GIS also can recognize spatial query and attribute query of all the spatial elements. The platform supports the inputs of keyword query and also supports the click of query element details on the map. And the system can provide a spatial statistic function of traffic semantic data and display it on the map in the form of thematic charts such as road length statistics, construction fund statistics, maintenance cost statistics, and traffic flow statistics, and so on. Network analysis is a basic analysis in GIS, which can analyze the path design of two locations and lists all routes available. So it can be the shortest route or the route cost least time. At the same time, with the mobile application development, route navigation between 2 points can be realized. For the problems found in the process of petrol inspection, professionals can input the detailed information, location, label, and other information of the problems through the mobile terminal for reporting. At the same time, the reported issues are stored in a specialized database, which can be displayed and managed in the platform. The issues maintenance status can be checked on the map. The red icons represent issues that have been submitted but not fixed, and the yellow icons means the issues are being solved. The green icons indicates that the problems have been solved and passed the acceptance. Besides, users can also check the details of every event. For emergencies, GPS is used to locate the incident. Users can quickly fill in the information, assist multimedia means such as photographing, hand drawing, audio, clearly displays the set status so as to realize real-time reports based on mobile network. Then the next, we are going to further learn about how to construct a more complete system of transportation business, or we call it one-man platform of transportation. Firstly, let's have a look why the system needs to be improved. There are many other businesses applications need to be integrated in the system. Railway business, aviation business, transportation. Each of them has their own business requirements. So how to assist the industry to share and integrate spatial geographic information resources, and how to integrate the various business applications into one system, and how to save the construction costs of industry spatial data management, improve the quality of data service and user experience. So this is what we are going to solve. Then let's also look at what are the challenges of transportation GIS. Firstly, with more and more GIS data generated, how to manage, store, and update the increasing information. There is also a large number of repeated and decentralized spatial information, and how to optimize it. In addition, there is a lack of unified standards for the management of spatial information, and a lack of spatial space information sharing mechanisms and technical means. Also, with the development of internet electronic map, how to construct a system that's more professional and more reliable and more practical applications. Also, with these questions here, we propose the DIKW model to solve the deepening industry application. It is development model from data to wisdom. In the traditional way, we always solve problems according to the data we have, so we can only do a few applications around the data. But if we further integrate the data extract the variable information, we can do much more applications. And the further development, future development direction is to solve the deeper industry problems in a more intelligent way. So here we propose Transportation One Map, which can integrate transportation industrial spatial resource, provide application foundation of traffic spatial information, and be a platform of spatial information sharing within the transportation industries. It shows how to realize information spatial splicing based on one map. The first level is City Department of Transport, which provides local transport thematic data, road network, railway network. The second level is Province Department, which aggregate provincial traffic semantic data to the one national department. Here, so the main ideas of Transportation One Map can be understood like this. The business information integration of each region can be spliced in space to achieve a complete picture. This vertical business integration and horizontal regional splicing spatial information framework is called One Map. The steps to realize One Map integration are data collection, information integration, service sharing, and finally realize intelligent management through cloud technology. Based on the above ideas, we have developed the open framework product of One Map and formulated the standard system. The traditional model is to develop a specific business for a requirement, but the new platform integrates multiple industries into one system through a unified GIS management platform, which effectively improve the resource utilization and sharing. Then let's take a look at what the platform should be built. The content includes three aspects: standard construction, data construction, and the system construction. Let's firstly have a look how to realize construction. There are three parts: management specification, data specification, and the service specification. The core construction is data specification. This part discusses how to standardize different types of data. For vector data, grid data, raster data, and other data, we need to standardize them, and then according to the data management method and the core metadata standard of One Map establishes the data classification system of One Map. Then the data classification system is divided into information service, graphic model, and interface specification, and their respective specifications are established to generate service sharing specifications. Besides, the management specification can be established by creating data document specification and data backup specification, so as to achieve One Map standard system construction. And the core content is how to convert data to service. Each industry data has its set of data. We provide classified storage based on the data standard, and each industry can be divided into general data and private spatial data. And the general the general spatial data can be integrated to one general spatial data and one traffic public spatial data. Finally, there are three types of database composed: transportation, geographic information data platform, general spatial data, which store basic geographic data, and traffic public spatial data, which stores traffic semantic data, and all the industry private spatial data. The next step is to realize the construction of transportation service platform after data classification. Firstly, we need to know the user layer, who will use the services and what they want to do with the services. And as the business department, design-making department and public, they have different requirements for this system. Therefore, we firstly need to publish static data as GIS general service to provide the basic functional services, and then dynamic data is published as data or information publishing service to provide real-time services, and the data mining results can be published as professional transportation services, providing statistical services and analysis services. Finally, mutual support is realized through shared service platform. Through data management and service management, a one-map system is built to realize the application to users and generate standard application services at the same time. And each level is based on its corresponding standards. So finally, the platform will form three types of service applications: map service, data service, and functional service. These applications can be obtained by accessing the platform, and each service corresponds its functions to meet the requirements of different users. Here, let's take a look at a case of one map application. This is one map platform of Jiangsu province transportation. The homepage integrates with data sharing module, service management module, public information publishing module, and provides application interfaces of resource center, development center, map center, and application center. And all business applications are integrated to the application center, including road application, railway application, airport application, public traffic application, port application, and so on. The second case is a traffic emergency command platform of Xinjiang province. This system not only integrates the information sharing and applications, but also provides emergency reporting and handling, as well as command and dispatching. The transportation one map is already a complete platform. The next, we are going to talk about how to optimize transportation construction with 3D technology. Firstly, why we need 3D technology? At present, many 3D entities have been formed in the main roads, bridges, tunnels, and culverts, especially the main connecting lines and the roads around the city are mostly complex overpasses, and with lack effective 3D display means. And traditional maintenance is mostly based on the management and applications of 2D vector data, lacking the ability to restore the terrain around the road to 3D scene and cooperate with emergency rescue to develop an overall solution. So we need 3D technology to display the 3D entities and make an overall solution with this 3D analysis. So let's look at how 3D GIS assists for transportation construction. Firstly, 3D GIS provides better visualization of reality scene. So we can view the sky, the objects on the ground, even the objects underground at the same time. It also can solve practical problems such as the height design of overpass and display interior space such as the tunnel model. Meanwhile, 3D technology makes the intelligent thing as possible. You may wonder what kind of 3D model are supported. Here lists some main 3D models like oblique photography, beam, point cloud, and fan 3D scene, 3D terrain, fan models, and we also can symbolize the 2D the 2D or 3D max. And we also support, and the 3D pipeline can also be supported to display in the 3D scene. The way to match multi-source 3D data is converting 3D model to a format that gets too accessible. The model integrated model, the attributes and the consistency between graph and model need to be ensured after data viewing. So each model is added to this scene as a layer. Here, let's see some cases of this 3D model viewing. The first one is the integration of 2D vector line with oblique photography with by 3D symbolization. And this is the integration of 3D model of professional modeling software and GIS. It shows how to symbolize 2D line with 3 and integrated the 2D line with the oblique photography. Here is a fan model which integrated in the GIS. And this video shows the integration of beam with oblique photography, 3D terrain image, and other geographic data. The status of the viaduct under construction and the work site as well as the terrain around it is vividly displayed. 3D GIS also provides many analysis functions. There are four aspects: 3D spatial expression and 3D functional operation, and it can also be exported to print 3D and convert from 3D to 2D, and also it supports customized development. Here is some results of 3D analysis, 3D slope and aspect analysis, and this 3D isoline analysis, profile analysis, 3D buffer analysis, which can also be used in the transportation construction. And the minimal vertical clearance often needs to be sure in the design stage. So this 3D model can view display and measure the value. The tunnel body model is built by convex hull, and the spatial operation between convex hull and the mounting body is realized to dig the tunnel. 3D analysis can also realize some 3D spatial relationship queries and judge the relationship between two spatial entities, including contain disjoint, overlap, and intersection. This example shows the intersection results of subway and building, and the buildings that intersect the subway are highlighted display. In the practical application, integrated 2D and 3D technology, the system can display 2D and 3D integration scene, view the overall status with 2D view, and meanwhile display core construction scenes with 3D model, monitor the construction status, and check check the risk sources. And also query and highlight the risk sources. Meanwhile, in the mobile terminal, it can realize 2D and 3D integrated visualization and 2D and 3D integrated navigation, as well as indoor and outdoor integrated navigation. Finally, let's take a look at the application of big data in traffic development. First of all, we need to briefly know what constitutes the big data GIS technology system. Cross-platform GIS and cloud GIS is the basic technology of big data GIS, and the core technology of SuperMap big data is big data storage management, big data distributed analysis, stream data, and big data visualization. We already know the diversity of traffic data sources, but how to store the growing amount of basic geographic data and thematic data, also the real-time traffic data, and how to highly efficient display them. SuperMap provides SDX and distributed SDX to solve the storage issue of big data. Let's take a look at the result of amount of 450 million line data based on HBase storage. It is displayed smoothly in the system. And the big data analysis operators based on SuperMap and Spark are growing. SuperMap provides different analysis operators for four types of data. Based on this analysis operators, the results of big data analysis can be displayed in a deeper level. Unlike OD analysis, the principle of OD analysis is to mine and analyze the starting and ending points of traffic and the connection degree between stations from big data. The video shows the comparison of morning and evening peak flow between two subway stations of Beijing. Like OD, it is planned to build a road across the whole area, and all influence land parcels need to be found out. This example shows the display of large number of land parcels with 10 distributed clusters, then do buffer analysis and overlay analysis to calculate the occupied land parcels, which only takes less than 40 5 minutes or seconds. It is planned to build integrated with IoT technology. Big Data GIS can realize real-time monitoring through streaming data service and distributed service, as well as big data analysis. In this example, real-time query of road conditions is realized based on distributed big data analysis by accessing real-time traffic flow data. And this video shows the statistics of taxis get-off points in the evening rush hour based on big data hotspots analysis. This example shows the number of global airplanes in a certain period of time based on big data aggregation analysis. So that's all for my presentation. Thank you for your listening.